Let's keep on going. A person stands on a scale inside a rocket that is launching vertically upward from the Earth with increasing speed, which means it is accelerating. Consider the following four forces: FPS, the force of the person on the scale; 2. FSP, the force on scale on the person; 3. FPE, the force of the person on the Earth; 4. The FEP, the force of Earth on the person. Which of the following correctly rank the magnitudes of these forces during the rocket's upward acceleration immediately after launch? The first thing we can get is this force and this force is an action and reaction force pair. Also, this force and this force is also an action and reaction force pair, which means the first force and second force are equal. The third force and the fourth force are also equal, which means we can already cancel out two options, which are A and B. Let's compare which of them is bigger. But one thing you have to remember is that on the scale is actually measuring your normal force. Measuring your normal force, not your gravitational force. In physics world, we call it your true weight. Imagine this: you're standing on a scale, right? And the scale is measuring the force that it needs to keep you from your position, like keep you staying in your position, not the force that you give to the scale, the pushing it downwards. It's measuring your normal force, which is this force. You have to remember this. So let's see. On the ground, yeah, you're on the ground, right? And you're standing on the scale. Let's draw a free body diagram of you. This is you, and you have obviously you have gravitational force, and you're standing still on the ground, right? Which means you're at equilibrium. It definitely has an opposite direction and equal magnitude of force, which is Fn. In this scenario, Fn is equal to Fg. However, if you're on the rockets, right, and you're standing on the scale, and because of the rockets is launching vertically upward from the Earth, also accelerating, which means you're in the rockets, right? Which means you're also accelerating. Let's draw a free body diagram. This is you. There's a normal force pointing upward, which is Fn. Obviously, you have a gravitational force, right? Because you're launching upwards, let's write a free body diagram. Then that force is equal to Fn minus your gravitational force, which is Fg, is equal to ma. A is bigger than 0, which means Fn minus Fg is equal to ma is also bigger than 0, which we can get Fn is bigger than Fg. The normal force is actually bigger than Fg, which means, yeah, Fn is bigger than Fg. So let's see which one is bigger. FPS, the force of person on a scale in the rockets, right? So, which is, yeah, the Fn, so which means the normal force in this scenario will be bigger than the normal force or the number on the scale if you're on the Earth, which means D is the correct answer. No, wait, actually, C is the correct answer because this one is the force you can see on the rockets, and this force is the normal force or the force you will see on the Earth. So C is correct.